For our fluid mechanical dissection, we were tasked with analyzing a chainsaw. After taking it apart, the component that we wanted to analyze further was the carburetor. A carburetor is a fluid mechanical device that mixes fuel into the air on its way to the combustion chamber. They typically consist of a choke valve and throttle valve that, when open, keep the air-fuel mixture at approximately the required ratio for the combustion reaction in the cylinder assembly. In order to mix the two fluids together, carburetors make use of the Venturi effect.
The Venturi is a tube which converges, speeding up the flow of the air, allowing it to mix with the gas. We can show that the tube is able to do this by applying conservation of mass to quasi-one-dimensional flow, which shows that decrease in the area of the flow will result in an increase in velocity. Bernoulli's equation then shows that this increase in velocity will result in a decrease in static pressure, assuming steady incompressible flow that's envisaged.
Building off from that, the Venturi tube is a vital part of how the carburetor mixes the fuel. Inside the tube of a carburetor, there's a throttle and a choke valve, which manages the airflow intake of the carburetor. The throttle valve is for upstream airflow, and the choke valve is for the downstream mix flow, essentially managing the speed of the tube. In this tube, the flow gets constricted through the Venturi effect, which creates a large pressure drop, increasing the airflow through Bernoulli's equations. That is, which is shown in the bottom here, that P plus 1/2 rho V1 squared, plus rho GH, which we mentioned previously. The pressure drop created in this vacuum-like area pulls the fuel from the reservoir inside the carburetor through a small hole called the jet. There, the airflow gets restricted and the flow becomes a gas-airflow mixture, ready to supply the engine with the chainsaw. The speed at which the fuel is flowing is also determined by the pressure drop from the Venturi tube and ergo the airflow. The main airflow is then finally determined by the
The carburetor on our chainsaw differed in many ways from the idealized models we typically look at. One characteristic that stood out immediately was the irregularly shaped inlet and choke valve of the carburetor. Since the fluid that first enters is just air, the design of the choke side should focus on enlarging its area so as to maximize the effect of the Venturi of speeding up the mixture at the throat. Because of this, the choke side of the carburetor is noticeably larger than the throttle side. We don't really care about the flow detaching in this portion of the carburetor. But another aspect that stood out to us was the diverging section being much longer than the converging section of the carburetor. On the throttle side, we want the flow to be smooth as it approaches the combustion chamber in order to maintain the appropriate air-fuel ratio for the combustion reaction. For that to happen, the diverging section must enlarge at a low incidence angle in order to prevent flow separation.
Carburetors are generally standard for similar engines. However, larger engines require more fuel, which means that they use carburetors with more than one Venturi, usually with 2 or 4 barrels. Although the output of these carburetors increase, this results in an overall loss in efficiency. Cars have shifted towards fuel injection systems, which tend to have better performance and efficiency. Because these systems are more expensive, they are not found in cheaper applications with smaller engines, such as chainsaws.